The very first Swedish nuclear reactor was recently decommissioned. This is a cross-section of the reactor station. The demolition of the reactor's iron ore concrete shielding began in August 1982. Some 300 cubic meters of concrete, including the bottom slab, were demolished. The shielding was not just reinforced in the conventional way, but a large number of heavy steel beams and steel liner tubes were also embedded in the concrete. After dismantling the reactor vessels and graphite blocks, Rivning started the demolition of the concrete shielding. Using the electro-hydraulically powered, remote-controlled Mini-Max machine, the concrete shield was chiseled from the top downwards. In this way, non-contaminated materials could be separated from those contaminated. The demolition rate was determined by the large amount of steel, including a heavy steel cylinder in the upper part, 20 millimeters thick, 2 meters in diameter, and 2 meters high. All steel material was cut manually into pieces to go into special boxes. When chiseling the iron ore concrete, a lot of dust was raised. To eliminate the dust with the least possible amount of water, the water spraying was controlled by the same push button as the chiseling operation. The water was thus ejected only when chiseling. Only 40 liters per hour were required. By mixing water and compressed air, the water particles are broken down to the same size as the dust particles. They then become more easily attracted to each other. The debris was put in special steel boxes. To facilitate loading, a steel funnel was fitted on top and a rubber skirt around the box. Each box was weighed. Then it was transferred to a monitoring station where the nuclides and the activity levels of the waste material were registered. Concrete with an activity level below 5 kilobecquerel per kilogram was deposited at a dumping site and covered with soil. Boxes containing concrete with an activity level above 5 kilobecquerel per kilogram were sent to a special waste depository. To make it easier and faster to change from one attachment to another on the Mini-Max, and thereby reduce the radioactive dose for the operator, we developed a quick connect coupling. The lower part of the steel cylinder is being lifted up. Now only the inner radioactive concrete layer remains to be chiseled. The use of the Mini-Max machine meant improved working conditions. The entire demolition job was done by 3 men only. Drilling and cutting or blasting would have required many people and been rather unpredictable because of the many steel beams and reinforcement bars. The electrically powered machine gives a better working environment than pneumatic tools do. The operator can stand at a safe distance and is not exposed to any vibrations. Rivning offered to do this demolition job for approximately half the originally estimated cost. Thanks to the efficient Mini-Max machine, they got the job and carried it out very successfully. Many contractors now profit from the Mini-Max machine. Why don't you join them?